Hello, fellow R programmers. Welcome to another session of social informatics in which we are going to focus on doing a thorough example with R. So today we are not going to practice together, learn together any more command in R. Instead, we are going to just do an example. And I believe it is an impressive example because you will notice with the thing that we have learned in R and the basics you have learned about programming, you can solve some problems. I'm gonna talk about the problem more. So, as I mentioned, today we are not gonna learn any more syntax, command, or function. We are gonna use just the thing we have learned so far together. So, at any time in the presentation, feel free to stop the video and do it on your own. Based on the things that we have discussed. No need for Google search, no need for any out of school advising session. Of course, you can ask me any question you have, but when I say out of school advising session means that you are going to solve this problem without the thing you already have on your canvas. Okay, here it talks about extending R. Extending R is some sort of symbolic name for applying R to do real problems because all the things we have learned so far together have been tools, have been techniques. But what about the main goal that is solving such problems? Okay, so we are going to check these two bullet together. It says before extending R, as I mentioned, using all the things, the package of R to solve real problems. The programmers should know the fundamental characteristics and background of R, and you know that now. You know the fundamental characteristics and background of R. You know many of the commands and functions that are very useful. So that's the point. So you have the first one, and the second one says extending R is supposed to cover the programming approach in R to support analysis and research projects. Exactly the same thing that I told you. It wants to use all these things in real world. And in fact, it applies to any field of expertise. You learn the basics, you learn the fundamentals, you learn about the background, and then extend all those things to real problem for inventions, for creations, for innovations, and all those things that very easily we can substitute all the things with solving a problem. Okay, so the problem I have selected for you is this. I wanted to choose a problem that is impressive. So when you make it done, you feel good about what you have learned and the potential, the potentials, the skill you learn have to contribute to your professional life. And just let me give you a heads up. The case that we are going to do is not easy to understand at first, and it belongs to the field of probability, statistics, mathematics, and even people with good knowledge of statistics, with good knowledge of probability, with good knowledge of mathematics, if they want to do it by a probabilistic approach, a statistical approach, or mathematical approach, it would not be easy. So that's the reason I'm telling you it would be impressive for you because you notice that just because of the fact that you have learned about programming and some uh, smart way of tackling the programming problems, you can do the problems that belongs to the other field of expertise first, and second, even the experts of those fields cannot do those examples easily. Okay, so let's check the problem together. And I told you, my friends, as soon as you notice you have a good understanding of the problem, just stop the video and do your best, and always feel comfortable. Feel free to reach out to me and discuss with me your approaches to do all these things. Because as I told you, we are not gonna do any new command in our class today, any new function. We are gonna do it based on what we have learned together. Okay, now let's read this together. It says there are 10 balls in a bucket that are numbered as 1 to 10. And somehow the bucket that you see here depicts this situation. So we have a bucket that has 10 balls, and balls have numbers on them 1 to 10. It says write an R code that calculates the probability of getting at least one ball with each number is calculates the probability of getting at least one ball with each number is if the sample size with replacement is n. You know about this replacement, my friend. Last week we talked about this. Was it last week? Okay, yeah. It was last week we talked about what does it mean? So it says with replacement, when the sample size, you know about the sample size also. We talked about it last week. So if you are not good with what we discussed last week, stop the video and go check the lectures belong to last week another time. So what does it mean, my friend? We have the bucket here. Okay, let's get random numbers from this bucket together. Okay, and remember, it is with replacement. I'm gonna take a random number from the bucket. The first I get is, it is the first ball, and for example, the number is 7. I return back the ball inside the bucket. And what is n here? What is the sample size here? Let's go for 6. Okay, so we are gonna take 6 number out of this bucket and write down the numbers. So the first one I pull out is 7. The second one is 5, for example. The third one is 9. The fourth one is 7, because it's possible, because it is with replacement. I put back the ball. Now I have 4 balls picked out. The next one I go 8, and the 6th one is, for example, 1. Okay, now it says check the probability of the fact that with 6 pulls out of the bucket, I get all the numbers from 1 to 10. There are 10 balls in a bucket that are numbered as 1 to 10. Write an R code that calculates the probability of getting at least one ball with each number is if the sample size with replacement is n. So it says calculate the probability if the sample size is 6. What is the probability that we get all the numbers from 1 to 10 at least one time? There was an at least, yeah, getting at least one ball with each number. So it means that we have at least 1 1, we have at least 1 2, we have at least 1 3, we have at least 1 4, we have at least 1 5, and like that. And I did it. First of all, is this a success experiment or a failure experiment? Because it's going to be a success experiment if we have all the numbers from 1 to 10 at least one time. But of course it is a failure. Of course it is a failure. Why? Because we don't have 2, we don't have 3, we don't have 4, we don't have 6. So it is a failure. But we have, for example, 2 7. And of course you agree with me that if, now it is the hint, if n is smaller than 10, the probability is 0, because, for example, if you are taking 9 balls out of the bucket, the maximum number of balls with different numbers is 9. So when you take 6 balls, the maximum number of balls with different number that you can take is 6. So of course you cannot take all the numbers from 1 to 10 when you are taking only 6 ones. So what is the main point that we get here? We need to at least get 10 balls out of the bucket to have a chance of success. Let's go with another experiment while n is 10 and it is a success. For example, the first one I take is 7. This is the first ball. The second one is 5, 9, 8, 1. You have 5. What is the next one? It cannot be, if I want it to be success, it cannot be any of these numbers, because it is 10 and only I have one chance for each number. So the next one is 6, for example. 6, 7. The next one is 2, 3, and 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. And also 10. So here, my friend, we don't have also 10. So you see, it is a success experiment while I took 10 balls out of the bucket. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I took 10 balls out of the bucket, and now I have all the numbers here. I have 1, I have 2, I have 3, I have 4, I have 5, I have 6, I have 7, I have 8, I have 9, and I have 10. So it's a success one. The other point that is, I'm just explaining the problem to you, okay? So here for the next one, it says with more samples, the probability would be higher. That's correct. Because if instead of 10 balls, I take 20 balls out of this bucket, the chance of having a successful experiment in which I have at least one number from one ball from each of the numbers from 1 to 10 is higher. If I have 30, of course, the chance of success is higher. And also I removed one is that was here, and now it is much better. So let's check the example again together. There are 10 balls in a bucket that are numbered as 1 to 10. Write an R code that calculates the probability of getting at least one ball with each number if the sample size with replacement is n.